Good morning, ladies and gentlemen. Today we're going to be covering the final section of Work and Energy, which focuses on power. Okay, and I'm going to start you off with a prompt on cars. Okay, because I'm sure you guys have all heard of the word horsepower before, but what exactly does that mean? So let's say we have two cars and they are exactly the same, except one has a more powerful engine than the other. What difference is that going to make? Okay, you might say one car is going to go faster than the other. One car can accelerate faster, so on and so forth. And for the most part, you would be correct. Now, what is power? In the world of physics, power is a rate of energy transfer. Now, what exactly does that mean? So, in terms of the car, what is doing the work? What is doing the work is the engine. The engine is doing the work. But the engine has to transfer that work to your tire. Okay. The engine, the pistons are moving, but none of that matters if it doesn't get to the tire and starts rotating. So, how fast that energy can go from the engine to the tire is what horsepower actually is. Okay. It is not a measurement of how much work the engine can actually do. It is how fast that power or that energy, I'm sorry, it's how fast that energy can get to the tire. Okay. So let me give you some examples. Let's say you have an engine that can do a thousand a thousand joules of work, but it takes 2 seconds to get to the tire. Okay, that's going to give you a 500. But let's say you have a second engine that's a little weaker. It's weaker. It can only do 500 joules of work, but it can get that energy to the tire in 1 second. So here you have a weaker engine, but because it can get it to the tire faster, you get the same amount of power. So technically, both of these engines would have the same amount of horsepower. Okay. So horsepower or power in general is just a rate of energy transfer. That's all it is. Okay. It is just a rate of energy transfer. I guess we live in the realm or the era of internet. So for those of you that are still not understanding, let me give it to you like this. So let's say you are on Netflix and you're trying to watch your favorite show, but for some reason things are lagging. It's taking forever for the video to load up. It doesn't want to load up, or it looks all staticky because you can't get that HD because you don't have enough internet connection. So when you're streaming something online, information is being transferred. But if that rate of information transfer is slow, then you get slow buffering, you get lag. So compare that to power. If you have low power, in this case, if you have low internet speed, you have a low rate of information transfer. If you have a low rate of information transfer, things take forever to load. In the world of power, if you have a low rate of power, let's compare it to the car, it it's not it doesn't affect your top speed. Let's say you want to get to 100 miles an hour. You will get to the 100 miles an hour, but it will take you a very long time if you have a low power because the rate of energy transfer is low. So it's taking forever for the engine to get that power or that energy to the tire. So power is just a rate. That's all it is, just a rate. And this is an alternative form. I like this one better just because I mean you use them for different things. Okay, so this is force times speed, and this is work divided by time. They're used in different scenarios, but they technically both give you the same unit. So they will both give you units of power. I just like teaching it with this one just because it's easier to see what I mean by rate. Okay, this is a rate. This is something per time. This is a rate. This will give you something per time, but it's not as easy to see. So the units for power are joules per second. Remember that joule is a unit of energy and it's a rate, so it's joules per second. It's okay, energy per time. Okay. It is also called a watt. A watt is equal to a joule per second. Okay, so W, which is watt is equal to, this is a horrible color. I always forget to change it. Let me do red instead. Okay, so a watt A watt is a joule per second. Okay, a watt is equal to joules per second. So when let's say, I don't know if any of you ever looked at your electric bill. Okay, they charge you based off kilowatts. Okay, they do kW, which is kilowatt, but kilowatt is power. It's a unit of power. It is how much electricity you're using per time. Okay, it is rate of energy transfer. How much energy is the electric company transferring to your house? Okay, that is power. Okay, that is power, but that is what. Okay, that is all power is. It is just a rate of energy transfer. Okay, that's all it is. And we'll do some practice problems momentarily. So now how to get accustomed to some of these labels. Let's say you're at Home Depot. You're at Home Depot and you're trying to buy a light bulb, and you see that the light bulb says that it is 100 watts. What does that mean? It means that when you flip the switch and you turn on the electricity, this light bulb is going to use up 100 joules of energy every second. That's what it means to have 100 watts of power. Okay, so when you flip the switch, that means that light bulb is going to be using this much energy every second, and you can use that to calculate how much it's costing you to have that light bulb. Okay, so some light bulbs are better than others in terms of efficiency. Some give you the same brightness with less power and things like that. And that's why, you have high efficiency light bulbs. I mean, different light bulbs serve different purposes. You have your fluorescents, your originals, and things like that. But this is for the label on them. When you see the power, what does that mean? It's telling you how much electricity it's going to use up. That's what that number's for. And this is just a practice problem. And that's actually the end of this section. So the power section is pretty short. It's not super complex. Again, power is just a rate of energy transfer. That's the key part. Okay, just know that. Power is rate of energy transfer. How much energy you are using per time. And we're already good on time. We're at the 7-minute mark. Okay, I'm gonna try to cut this off at 15. Because again, nobody likes watching 30-minute videos. I had to do that a lot in college myself, and I was not a fan. So let's do some practice problems. I'll start with the ones down here. Again, I'm doing the one with no key. I'm actually switching it up this time. So because, again, spring break starts on Friday, normally I have you do the key one day and then the one without the key the next. I'm actually going to do it all at once. But again, the one with the key is never due for submissions. The one with the no key is the one I really care about because obviously it doesn't have the answers. That's the one you have to work for. I'm going to start off with these. It depends how much time we have. I'm going to try to get through number 6, and if we're still less than 15, then I'll do one more after that. So you only need one equation for this. Power is equal to work divided by time. These are the equations you're going to be using. I'll actually write one more equation for you because you might need it, and I think we will for number 6. What is work? So W is work, but what is the equation for work? If you remember from the previous section, work is equal to force times displacement, okay? Work is force times displacement. So let's look at number 6. What are we looking for? Our final destination is power. So we're looking for P. If we're looking for P, we need W and we need T. What are we given? We are given T. We already know T. T is 16.7. But we are not given W. We are instead given what? We are given a distance and we are given this individual's mass. So now let's read through the problem just so we can be on the same page. So what you have here is you have somebody who threw a disc and that disc stayed in the air for 16.7 seconds. It says here that this individual ran up the stairs in that same time. So he ran up some stairs in 16.7 seconds. And he went up a total of 18.4 meters. We know his mass. With that mass, we can actually calculate work. We know the displacement. Displacement is 18.4. And how much force was needed? Well, what is he moving? He's moving his body. So the force that he's applying is basically his weight. So what is force in this case? Remember, force is just mass times gravity. So in this case, our W is going to be the 72 kilograms that he weighs, or that his mass. I'm sorry, that's his mass. So it is the 72 kilograms, which is his mass, times 9.81. Okay. This whole thing right here is your force. Okay. This 72 times 9.81, this is your force. Okay. This is F. And then we need to multiply that number by the displacement. And the displacement is, again, 18.4. So for the work, you would do 72 times 9.81 times 18.4. And that will tell you your work. Okay, so that's your work. And then you can find your final answer. After you get this number, whatever this number is, just divide it by the time, which is 16.7. So if you want, let me show you what your final answer would be. I'm not going to calculate it for you, but I will write it out for you. So for number 6, your final answer is going to be this. P is equal to your work, which we calculated. The work is 72 times 9.81 times 18.4. And then you take that whole thing and you divide that by 16.7. Whatever you get here, that is your answer for number 6. Boom. Number 6 is done. Plug and chug. And we're at 12, or about almost 13, so I will do one more. Again, I always start from the bottom because these tend to be organized by difficulty. The higher the number, the harder it is typically. And then let's do number 5. What are we looking for? We're looking for power. What is his average power output? So we're looking for P. If we're looking for P, what do we need? I always tell you to start at the end. What are you looking for? And then after you know what you're looking for, what do you need to get it? So we need work and we need time. Let's look at what we have here. We're throwing a boomerang and we catch it at the same location 3 minutes later. So that means the boomerang was flying for 3 minutes. And then this individual decided to work out while waiting for the boomerang. If he expended 54 kilojoules of work, what was his average power output? So this one doesn't require us to do any extra calculations. Work is equal to power, power is equal to work divided by time. What is the work in this case? The work in this case is 54 kilojoules. Okay, pay attention to the unit. That is a kJ. Okay, that is kJ. That is kilojoule. Okay, we need to go from kilojoules to regular joules. And to do that, you got to multiply by 1,000. So this would be 54,000 joules. Okay, so this is 54,000 joules divided by, now we need to change minutes to seconds, okay? From the slide, it tells you that the unit for power is joules per second, which is why I had to change kJ to regular J, and now we need to change minutes to seconds. How many seconds are in 1 minute? 60. And if we have 3 minutes, you would just do 60 times 3, So we have here 180 seconds. Okay, so you plug those numbers into your calculator and you get your answer for number 5. So boom, that's number 5 and number 6 done. So all you got left is 1, 2, 3, and 4. And as I look through 1, 2, 3, and 4, I do not see that any of them have any special nuances. Okay, yeah, no, this one is straight up. This one is straight up. This one is not straight up. Let me see. Actually, no, this one is. This one is. No, you're good. Okay, so these are not especially complex. So you guys should be okay. And where are we on? I think we're at exactly, okay, we're at 16. Cool. So this is power. This finishes off work and energy. The next couple of days is just going to be review, and then you have your assessment on Thursday. Remember, spring break is officially on Friday, so there is no work for Friday, and you will have no work all of next week either. Okay, so spring break goes until the 20th, or until the 19th, and the 20th is the start of the next thing again. So just get spring break start next week. No online work will be assigned during that time. Packets are being sent out for those of you that need it for the next one already. And that's power. Okay. I wish you the best of luck.